Hi everyone. We will be solving LeetCode 1822 today. It's called sign of the product of the array. In this question, we need to implement a function sign func which takes x as a parameter and returns 1 if x is positive, minus 1 if x is negative, and 0 if x is equal to 0. That means whatever we pass in this function, if that is positive, so this function returns 1. If that value that is x is negative, then it returns minus 1. And if it's 0, then it returns 0. So we are given an array nums and let product be the product of all values in nums. So we need to return a sign from product. So it's uh, It's telling that if we pass this product as the parameter to this function, so what will be the result that we have to give as output? For example, here nums is minus 1, minus 2, minus 3, minus 4, 3, 2, and 1. So we will product all the elements. So we would get 144, which is a positive value, right? And we know that in case of positive value, we return 1. That's why the output becomes 1. So I hope the concept is clear and you are clear that what we will be doing. Also, we are given the constraints. Uh, the array length can go up till 1000 and elements will be in this range, minus 100 to 100. So let's head over to the approach. So I have written the sample case again. So we know that the length can go up till 1000 and nums each element can be from minus 100 to 100 in this range. In this video, I will also tell you how to, read the constraints and derive solution from it. So here we will know that in the importance of constraints. So the first idea you might think of is let's just multiply all the elements and then compute the product. Like here, if we multiply, we get minus 1 into minus 2 into minus 3 minus 4, 3, 2, and 1, which gives 144 as result. And we check it's a positive number, so we return 1 as out. So here it works, but suppose what's our worst case? The length can go up till 1000. So suppose we have 1000 elements, and let's take every element is 100. So it's 100, 100, comma 100, 1000 times. Suppose 100 is there. Then, in this case, in such scenarios, we can't product every element, right? Because it will overflow our value because there is only a particular range which we can store in integer or long variables. Even long would fail in this case. So we are clear that we won't be doing product of all the elements at least because that would fail for larger values. So what we would do is smart work. See, let me write the array again. So it's minus 1, minus 2, minus 3, minus 4, 3, 2, and 1, right? So we know when a negative element is multiplied with another negative, we get positive value. Similarly, if positive is multiplied by positive, we get positive. Similarly, uh, positive into negative is negative, and negative into positive is negative again, right? So we will keep this in mind. So I hope you can see the pattern. So if there are let's say even number of negatives. Suppose there are uh, six negatives. So the pair will cancel out and become a positive value. Like what I'm saying is, suppose you have 6 times minus 1. So this and this cancels and becomes positive 1. This and this gets cancelled out and becomes positive 1. And this cancels out and becomes positive 1. So resultant is plus 1. So what I'm saying is, if there is a negative value and we get another negative value in our array, then they multiply and give a positive value. So the negatives will cancel out eventually and give positive values if they are even in number. But if they are odd in number, like we have minus 1, minus 2, and minus 3. So magnitude is 6, we know, 1 into 2 into 3. And about the sign, this and this gets cancelled out, but we get this minus remaining. So this gives minus. So if number of negatives is even, then they will cancel out each other and result in a positive product. So if the number of negatives is even, the product is positive. And if it's odd, then it's negative. So this will be the idea. This is the idea we will be using. So, and also, if suppose we have something like 100 minus 20 minus 30, 0, 5, 7, minus 23. So, if anywhere we get 0, then definitely product is going to be 0, irrespective of what other values are. So, this thing is also a one catch we should take care of, that whenever if we encounter even a single 0, then we directly return 0, because whatever be the other numbers, the product is ultimately going to be 0 only. So this was the approach. Now let me code it up, and then things will become more clear. So I've written the code of the sign function. So it takes nums as a parameter, and we take one variable called negatives, and this is used to count the number of negative values we have in our array. So we process the array and check every element in the array. If the number is 0, anywhere we encounter 0, we directly return 0 from here, because whatever with the other numbers, if once we get 0, product will ultimately be 0 only. So that's why we return 0 from here directly. Else, if our number is less than 0, that means it's a negative number. So we increase the value of negatives. See, this variable is just counting how many negative values we have in our array. So if num is less than 0, so we increase negatives variable value by 1. At the end, as I told you, that if number of negatives is even, this is used to check whether a value is even or not. If on divide, it means modulus is used to give remainder. It's used to give remainder. So suppose 5 modulus 2, it means if we divided 5 by 2, we would get 1 as remainder. So it would return 1. So for even values, we know even values are completely divided by 2, right? So this will always give 0. So that's what the check I have put. So if negatives modulus 2 is 0, that means number of negatives is even. Then we return 1. If it's not 0, that means it must be an odd number. So that in that case, we return minus. So this was the entire approach. I hope it's clear. Coming to the time and space complexity. Since we are traversing the entire array, time complexity is big of n, and we are taking no additional space, so space complexity is big of 1. So this is our time complexity and space complexity, big of n and big of 1. So I hope the approach is clear, and this was it for today's video. Thank you so much.